All right, so the new unit is on logic, as you can tell from the packet. So symbolic logic is an area where mathematics of using symbols to represent statements and arguments. It's kind of like a shorthand. You're basically just abbreviating using, it's kind of like using a code. You're just using a code to summarize statements and arguments. Logic helps us determine the validity of statements and reach conclusions from assumptions. So we'll talk about different rules later on. So, a simple statement. A simple statement is a sentence which is either true or false, but not both. This is very important. It can't be both. It can be true or it can be false, but it cannot be both. So, for example, finite is a math class. Okay, that's a true statement. Graduation is in June. It's a true statement. Okay, you could say February has 35 days. Well, that's a false statement, but it's a simple statement. It's false, but it's simple. It's just not true. All right, non-statements. If you yell at somebody, don't tell her, that's a command. It's not a sentence. Now, that's a question you're asking someone. It's just a simple one-word question, but it's not a simple, it's not a statement. The freshman year of the class of 09. That's like if you're announcing the freshman class of 09. But that's not a statement, it's just a declaration. Who's here? All right? So, we also have logical connectives. Connectives meaning, words that combine two or more simple statements. So these words are and, or, not, and then if then. Notice how there's the three dots. These are tied together. You talked about that in math class before with a hypothesis, or in science, an if-then statement. Okay, so if then go together, but and, or, not, if then. Okay, so don't go, some people go, oh, and, or, but. We're not talking about prepositions. Okay, it's not all the prepositions, just and, or, not, and then if then. All right, so compound statement. Compound meaning more than one, just like a compound fracture is a break in more than one spot. Compound statement is the joining of two or more simple statements with the logical connectives. Okay, so we're taking two statements and using one of those four connectives that we just talked about. So example, I got a D minus. So that's one statement. And I almost dropped out that semester. Okay, those are two statements combined by an and. Seniors are the best. Or juniors are cool. Okay, two statements joined together by an or. If I go to the football game, okay, I go to the football game is a statement. Then I cheer on the Falcons. I cheer on the Falcons is a statement. Losing fantasy football in a week 3 is not permanent. Okay. All right, how about non-compound statements? More to come about the freshman year of the class of 09. Well, you're not making two statements there. You're just saying there's more to come about that declaration. So that's just a non-compound statement. All right, negation, which you can kind of get from the name of it. When you negate someone, you kind of say no. You counter their argument. So negating is incorporating the word not. Okay? So you could say, everybody's popular opinion, math is the best subject. I know most of you in here agree with that. That's a true statement, if I say so. But the negation would be, math is not the best subject. So it's kind of like dealing with the toddler. You tell a toddler, hey, it's sunny outside. No, it's not. They just like to negate you. Once they learn that word, they love to use it all the time. Okay? So an example, statement, x is greater than 10. The negation would be x is less than or equal to 10. And we'd have to say less than or equal because that incorporates both possible negations. If it's not 10, okay, if it's not greater than 10, it could be itself 10 or less than. So we have both of those. All right, moving on. Now, we're going to use the letters P and Q for statements. Okay? Now, if you think back to Algebra 2, we used P and Q when we were talking about factoring. Okay, and all the possible factors of a, quadratic or something higher, cubic, quartic, whatever. This is not the same P and Q. We're using P and Q differently. So I know many of you have Algebra 2 stuck in your head and you haven't let it go, but it's a different P and Q. All right, so for example, P represents, it's a representation, it's an abbreviation, we're doing code. P represents seniors will graduate in the spring. That's going to be a substitute. We're using just P for the entire statement. And then Q will be they will go to college next fall. Okay? Now, we talk about symbols and abbreviating. We use this tent-like thing, okay, the caret symbol from your calculator, for an and. We use a big old V, kind of a V, for R, or, sorry, not R, or. And then we use the tilde for not. Okay, which is also confusing because previously in math we would use a tilde for approximately. Well, here it means not. Okay, so P raised the roof caret Q. That means and, right? This thing right here means and, all right? So we substitute back in the statements we have. So seniors will graduate in the spring. We just write that. That's the P. And obviously we don't have to capitalize it when we write normally, but I'm just emphasizing it. They will go to college in the fall. So nothing super challenging. We're just substituting statements with letters. All right? Now, P, then that's kind of a V, and then the tilde. So remember, this means R, or, I'm stuck on that, and this means not, the tilde. Okay? So we're going to kind of start off repeating what we already said. Seniors will graduate in the spring. I'm going to abbreviate that. In the spring. Or they will not, okay, go to college in the fall. So we're really just breaking it down, and whatever we see, we're writing. And then we fill in the symbols of the appropriate words where we have them. Okay, so when we use the and symbol, it's called a conjunction. If you ever watched the old Schoolhouse Rock in grade school, conjunction, junction, what's your function? It's joining things together. So and is a joiner. So it's a conjunction of the two things. If we use or, it's a disjunction. So notice they both have junction in them, but this is for and dis is for or. Okay, so disjunction is or. Now we're going to talk about something that is pretty much only in logic, and they're called truth tables. And it's a diagram designed to determine the overall validity of compound statements. T will stand for true, F will stand for false. Pretty easy. So a negation truth table, okay, is just basically saying right here, if P is true, not P would be false. And if P is false, then not P would be true. It's just taking the negation. So if we have this thing, if true is false, and then the negation of a false is a true. That's all we're doing. Kind of common sense, nothing too tricky there. So in other words, if P, seniors will graduate in the spring, is true, then not P is seniors will not graduate in the spring, which is false. Okay? So we have the true statement and the false statement. Conversely, seniors will not graduate in the spring is true, then not P, seniors will graduate in the spring is false. Okay? So the negation of a truth is false and the negation of a false is true. Now, just like in algebra or math, if I just said negative 5 equals positive 5, because the negatives, cancel each other out, same thing here. A double negation is the same thing as just P. So it's just like in basic math, okay? A double negation, you undid it. So today is Monday. No, it's not. It's not Monday. Okay, well then it is Monday. If it's not, then it is that thing. All right. So we're back to seniors graduating in the spring and going to college in the fall. Now, remember, this symbol means and. Okay? So this is where it kind of gets a little more complicated because this is where the rules kick in. So we have P, Q, P and Q. So if P is true, they'll graduate in the spring, and Q is true, they go to college in the fall, that is true. Okay? So if P and Q are true, then the overall statement is true. But notice, if I have one false or two falses, it ends up being false. Okay? So this is very important right here. This is kind of a summary of that. The only time a conjunction, and we're only talking about conjunction here, is true if both statements are true. So any falsehood ruins the whole thing because we're saying this and that. It's very strong. This has to happen and this has to happen. So for the whole thing to be true, both things have to happen. So example, stoplights are red, go lights are green. If P and Q is true, because both are true. However, if I say P, the moon appears white and the sun appears black, P and Q is false because Q is false. Because the moon may appear white, that's true, but the sun appearing black, false. Okay? You can't say, well, what about an eclipse? Well, that's not the sun appearing black, it's just being blocked. So since this is false, it makes the whole statement false because one of the things can't happen. Now, disjunction. Remember, disjunction we're talking about or. With or, we're talking about not as tight of a requirement, not as stringent. All right? So as long as one thing, again, this is the big summary here, as long as one thing is okay, we have a truth. Okay? So true, true, true. True, false. Well, since I said either or is fine, good, we're true. False, true, still either or. The only time we're going to get a false is if they're both false. Okay? So or is a much less stringent requirement. As long as one thing's true, we're good because we're saying either or. All right? So for example, if P is 10 is greater than 8 and Q is 16 less than 9, well, 10 is greater than 8, that's true. 16 is less than 9, that's false. But if I say or, as long as one of them is true, the whole thing is true. Because I'm just saying or. All right? So, evaluating the truth of a compound statement will determine if a compound statement is true or not. All right. So, determine whether the following compound statement is true or false. So, P represents yellow as a color, B, banana as a color, lemon is a fruit. So, those are P, Q, and R. All right. So, we say yellow is a color. So, we just write the letter P. Or, so we're going to put that V thing there. Banana is a color. That's Q. And lemon is not a fruit. Not R. Okay? So it looks kind of weird and different, but it's really pretty easy. you're literally just translating. You're substituting P in for this. You're substituting Q in for this. You're putting in R for this. This is the tilde. This is that. And this is that. So we have P. I mean, you can even do it this way. Kind of break it down step by step in the statement, whatever's best for you. Now we have to analyze it. Okay? So, if we look at this, okay, this is true. This is false. Banana is not, I mean, you might go, well, I bought a shirt the other day and it was listed as banana. Okay, but generally banana is not listed as a color. So we're going to say that's false. Then we say that and false, because lemon is not a fruit, is, you know, going from there. So, with these two, we're just breaking down step by step. Since those two together are both false, and we said up here that we have two falses on an or, that's false. Now we have T, kind of the V, and then false. So we break it, we're working backwards and breaking it down. Okay, so these two falses, this and that, are false, so it's false. And then since we said T, V, F, okay, we go from there, and so we end up with a false statement. And we're just breaking it down step by step. We'll practice more, don't worry. All right. So, number 10. We have seniors are 12th grade, that's P. Freshmen are 9th grade, 12. Sophomores are 11th. That's R. Okay, let's get into that. It's a little weird. All right. So, seniors are 12th grade. So, that's our P. And, that's our upside down. I just wrote an A, I don't know why. Upside down V. That's our caret. And either freshmen, which is our Q, or our 9th graders, or sophomores, our 11th grade. So this is our or right here. So now we start breaking it down. Seniors are 12th grade. That's a true statement. And, I wrote an A again. I guess I'm thinking A for and. So and, then we have Q, which is our freshman or 9th grade. That's a true statement. Or sophomores are 11th grade. Well, that's a false statement. They're 10th grade. We all know that. Okay. So now we break it down. This ends up being true because as long as one of the ors is true, the whole thing's true. So what does that leave us with? T, again, not A. I'll keep doing that. T and T. Again, when we're talking about and, both have to be true, so that leads us to ultimately true. It's a true statement. Okay, so we just work backwards. We do two at a time, determine if it's true or false. Two at a time, determine if it's true or false. All right, let's keep going. Dogs bark, cats meow, chickens moo. All right? So, it is not the case, okay, it is not the case that dogs bark, so we're just translating, and chickens moo. Okay? So we keep the symbols as we go. Now, dogs bark, that's a true statement. Chickens moo, that's a false statement. Now, unlike algebra, you can't just distribute a negative sign throughout and make this F and T. That's a no-no. Now, there's two ways to do this problem. If you distribute, you can technically, you have to change it to an or. There's a special law in logic for that. Otherwise, it's best just to follow rules of operation and just do the parentheses first. And if you do the parentheses first, you'd end up with not T and F is false, and these both end up being true. because not false is true, and false or true is still true. So I would recommend going with this method. Just do this first. But there is a rule that if you distribute a negative, a negation, you change it from an and to an or, and vice versa, an or to an and. But that's a little tricky. So I'd say this one is kind of a harder one. I would just stick with the other. Finite is math. Miss Nilhouse is a teacher. She is the best. So finite is math. Okay, that's our P. And remember, it's like making an A, which I keep making a mistake on. So it's A without the crossbar. Nilhouse is a teacher. So that's Q. But she is not the best. But is kind of like an and. So we're saying and she is not the best. So we're going to be generous and say finite is math is true. Nilhouse is a teacher. That is true. And she is not the best, but the best part is the true statement. So we'll go with that. Give her the credit. Now, not true is false. So we'll say T and false. Because not true is false. Now we're going to do these two. Get the falses out of the way. So true and false, that's a false because they both have to be true with an and. So that leads us to true and false. This one, those two become that. And again, true and false leads to false. Because you have to have two truths when you're doing an and. Until you get used to this is a good thing to have the notes right next to you to remember, what the requirements are. But if you just think about it, common sense, it kind of makes sense. And need two truths to be true, or needs two false to be false. All right, last week was homecoming. Not true. If it was the first semester class, we might be there. Last semester was homecoming, so that's my P. And it is October. That's Q. And Halloween is next month. Okay? So, if this was first semester, we'd answer it differently, but we're going to go with it being now. So, last week was homecoming is false. It is October. Well, that's false. And Halloween is next month. Well, that's false also. Since we're dealing with a bunch of ands, we can save the time and see that this is definitely going to end up being a falsehood. Because if we break this one down to be false, and then that and that would be false, and we can just save time. Now, you don't have to write this down, but real quickly, if this was first semester when we were doing this class instead of second semester, then it would be last week was homecoming would be true if the class times out right, and it is October, and Halloween is next month. Well, that's false because if it's October, Halloween is not next month. Thanksgiving would be next month. So this would lead to a false, which then still those two would still lead to false. So it ends up being false regardless, just you get there in different ways. All right, number 14. Okay, I think this is the last one. Yeah, last one. Okay, given P is true, Q is false, R is false. All right. So we have P is true, or not Q, which is false. Okay, put that in parentheses. And not P, so we're saying not true. We're not translating here, we're just plugging in, this is P. So literally the P comes in here. We don't try to do the not P and turn into false yet. We literally just translate as we see it. So the P goes right there, true. And, that was way too big, not R. So again, we're just plugging the false in right here, so we're going to put a false. So, a lot going on. Now we're going to do the tildes. So, this means T or T, not false is true, and not true is false, and not false is true. Now we deal with the separate ones separately. So, true or true, that's true. And the and stays. False or true, sorry, my bad, false and true, it looks like an A. False and true, that's false. True and false leads to false. And that